Okay, so we have a Claude 3.7 Sonnet thinking model. Let's read this out loud quickly.
The code looks technically correct. It implements principal component analysis, PCA, using the Jacobi SVD algorithm for computing eigenfaces from images. Here's what the code does. Implements the Jacobi SVD algorithm for eigenvalue decomposition. Computes the mean face from the input images. Centers the faces by subtracting the mean. Forms a smaller covariance matrix, number images times number images, which is more efficient than using the full pixel dimensions. Applies SVD via the Jacobi method to the covariance matrix. Sorts eigenvalues and transforms eigenvectors into eigenfaces. Normalizes the eigenfaces and returns them along with the mean face. This approach is efficient because it works with the smaller dimension, number of images, rather than the larger dimension, number of pixels, which is common in PCA for image data. The implementation appears mathematically sound and should work correctly for eigenface computation.
Okay, what do you see on the screen?
I see a web page titled Eigenfaces, with some text, slider bars, and an image of a person's face. There are also 5 images above that look like ghostly faces. Do you want to know more?
Yeah, what's happening now?
The dot on the Eigenface 1 slider is being moved to the right. Is there something specific you would like me to observe?
Yeah, what's happening to the image below the sliders?
As the slider for Eigenface 1 is moved to the right, the image below the sliders starts to have its features become more pronounced. The highlights get brighter and shadows get darker.
How about now?
The Eigenface 2 slider is being moved to the right now. Is there anything specific about this change that you'd like me to comment on?
Yeah, how about now? What's happening to the image below the slider? So I'm moving Eigenface 3, and what's happening to the face below? Can you try and guess what it is all about?
Okay, the slider for Eigenface 3 is being moved to the right. The image of the face below becomes darker, and the nose and lips are more pronounced. As for what the sliders are about, it looks like each one corresponds to a different feature of the face, and when they are adjusted, these features are altered in the image of the face below. Does that seem right?
Yeah, that is correct.
Okay, now the Eigenface 5 slider is being moved to the right. The image of the face below now looks more like a negative image. Is there anything specific you'd like me to observe about this?
Do you know why the image is so low resolution? I was originally recording my camera footage with much higher resolution.
Based on the text at the top of the page, it seems that the eigenfaces displayed are the principal components extracted from the captured faces, meaning that they're not intended to be full resolution images. When you click Capture Face, the full resolution image is shown in the captured image window. Does that make sense?
Yes, can you have a look at it now? Like when I capture the face, the image is much smaller. We actually have another developer doing the code for us, so we need instructions for them to fix the code. What would you improve about this web application?
Okay, I see that the captured image is much smaller than the camera input image. Also, as you adjust the Eigenface sliders, the image at the bottom changes, but it remains low resolution. I would suggest keeping the resolution of the captured image and the adjustable image consistent with the camera input. Is that the kind of feedback you were looking for?
Yes, it might be. How much more computationally intensive that would be?
I understand. You're suggesting that processing and displaying higher resolution images may be more computationally intensive. Is there anything else I can help you with regarding this web application?
That's fine. That's pretty good as it is. Okay, so we're calculating Eigen vectors. We have another JavaScript code for that. Okay, just go into the chat. Okay, so we have, which one should we use? Let's use all 3 mini quickly. Okay, if you can, just a few questions about the code. First of all, how many captured images is the maximum? There seem to be, once we crossed a certain number, we seem to be getting like an error on the screen, but it just flashed briefly and I can't actually see what it is. There's no errors in the console. Oh wait, there are errors in the console.
The code doesn't enforce a strict maximum number of captured images. Every time you capture an image, the code adds it to the face images array and, if there are 2 or more, it triggers the Eigenface computation using all of them. The error you're noticing may be happening in the SVD/Eigenface computation.
Okay, we're still getting a few errors, and we have this mockup. So doing it different facial expressions. It's setting it as an eigenvector, and we essentially can change the features of that expression. That should be the first or the last. Yeah, would be that one. Yeah, we don't really need Claude anymore because we have it within IDE, within the development suite. The Eigen PCA analysis and Eigenfaces weights comparison.
Principal component analysis, PCA, is a statistical method for dimensionality reduction, while Eigenfaces is a specific application of PCA for facial recognition. They both rely on eigenvectors, but for different purposes. Do you need more detail on how they compare?
Yeah, can you keep it short and fun?
Sure. PCA is like finding the best angles to look at data. Eigenfaces are just PCA's way of recognizing faces, like a camera that picks up on key features to know who's who.
Okay, and what else can you do with Eigenfaces in terms of feature extraction?
Eigenfaces can help with feature extraction by identifying the most important facial features. This simplifies complex data, making it easier to match and recognize faces. It's like finding the unique fingerprint of each face.
Okay, we're actually looking at the web application at the moment that's using a camera and capturing faces and generating Eigen weights. It's actually reconstructing the image, I think.
Yes, that's right. The web application can use the camera to capture faces and then apply Eigenfaces to reconstruct and recognize them. It essentially simplifies facial data, making it easier to identify and match. It's a neat application of Eigenfaces.
Sorry, which web application are you talking about? I'm talking about custom one that we are developing ourselves.
Got it. For a custom web application, you typically use JavaScript and Python. JavaScript can handle the front-end camera capture, while Python, with libraries like OpenCV, can process the Eigenfaces on the backend. It's a powerful combo for building your facial recognition system.
Yeah, we're having quite a bit of trouble. We have a developer doing coding for us. Well, yeah, we're trying to improve this web application. Not sure. We have a very long code. Just listening in. Just say yep. Unless I asked you a question. Okay, so we have almost 750 lines of code, another 150 in the SVD computation. Any funny comments so far?
None so far. Keep going.
I had it.
You're on track. Keep it up.
No, I don't need encouragement. I need some funny comments, critical comments.
Got it. Coding's like a bad date. Awkward at times, but gets better with patience. Keep an eye on those SVD lines. They love to sneak in errors.
Let's go for Claude 3.7. Okay, so another question. The images captured seem to have a low resolution. Why is that? Anything specific in the code that limits the resolution of the image?
Looking at the code, the image resolution is explicitly limited to 50 by 50 pixels. This is a deliberate design choice to improve performance. // draw a 50 by 50 section of the video onto the canvas, reduced from 100 by 100. Const size equals 50, //
I don't know why reading the entire code, but yeah, so we have a limitation of the video. Okay, any suggestion what this size of the image could be? So the web application is still fast, but we increase the image size?
Sorry, I don't know what to suggest here since your query isn't asking for a directory structure for a project.
Okay, let's just go for coding. Oh, that was the thinking model, was it? Oh no, it was 3.5 Sonnet. Let's do like, yeah, 4.0 should be pretty basic stuff. Okay, quickly, can we double the size of the image?
Index.html. Double the size of the image by changing the size from 50 by 50 to 100 by 100 in the relevant sections. Existing code.
Okay, don't read the code to me. It takes some time, well, because the code is so long. Could have highlighted just that specific section. Yeah, whatever is working in the code, we can split up into a separate file. Okay, so that's a reconstructed image. Here we could use more in the explanation. Could have something like a random button, crazy button, that will just vary these sliders randomly. Should we do that? And no, should just keep it sane. Shall we keep it sane? Okay, currently we only have one JavaScript that does the SVD calculation. But can you look at the code and tell me how shall we break it into separate files? But keep it simple. I still want a single folder, nothing fancy. How much larger the image can be?
Collecting workspace information, filtering to most relevant information. Looking at your index.html file, I can see you have implemented SVD, singular value decomposition, for facial recognition using Eigenfaces directly in your HTML file. You also have a web worker implementation in svdworker.js for offloading the heavy computation. Here's how you could break this code into separate files while keeping it simple in a single folder structure. Recommended file structure /PCA/ index.html hashtag.
We actually already have that file. Should we break up the code that way? Will we only be getting into trouble? We'll keep it as simple as possible. Can we actually keep the image to the original video capture size? We should have done those in code generation. Then it would have just generated all the files.
Made changes.
Made changes. Great. Oh, and yeah, it actually didn't do anything. Okay, should we start breaking it? Let's have a copy just in case. Let's start from the bottom. We have the HTML. It's something manageable. 74 lines. We have main.js. Okay, this will be painful. I want them all in a single. Shall we have them all in a single folder? Yeah, wait a sec. We can do it. First, let's have a normal info text file. No CSS. Fix this. Okay, we don't need the modules. Okay, actually, let's try something else. Let's actually open a new VS Code. Let's do a Copilot edits. That's right. Okay, we have the HTML and let's use. Yeah, it's kind of important. So 3.7 Sonnet it is, and this is editing. Okay, so we have this very long HTML file. As you can see, we want to break it down in into several files. We already have this SVD worker JavaScript that's calculating the SVD, but we would like to break down the long HTML, mainly JavaScript, into separate files. But we want this keep the structure very simple, so like single folder, nothing fancy.
I'll help you break down the long HTML file into separate files to improve maintainability while keeping the structure simple. Let's create separate JavaScript files for different functionality and update the main HTML file to reference these new files.
Okay, so the thing is still working. That's good to know. I don't know what happened to that one. It's two different faces. It kind of seems like it doesn't really matter if you're making more than 5. Yeah, so it took these 5 images, Eigenfaces, the principal components, extracted from the captured images, and yeah, it's working pretty well. So I'll add a video at the bottom of the page of me using this web application, but we'll still need some more text description. Why are we limiting the size of the image? Can the size of the image be the original video footage or not?
We're using a fixed, smaller image size, 100 by 100, to ensure that the Eigenface computation remains efficient and can run in real time. By limiting the region to 100 by 100 pixels, the algorithm reduces the amount of data it has to process, which keeps memory usage and processing time low. This balance is important because while the original video footage may have a higher resolution, processing such large images in real time would increase computational costs significantly and could lead to slower performance and a laggy user experience. Although it's technically possible to use the original resolution, doing so wouldn't necessarily improve the accuracy of the Eigenface extraction and would likely hinder performance.
Okay, but I still don't understand. So first of all, there seems to be a limit to how many images are actually used. There seems to be a limit of 5, because in the Eigenfaces we're not displaying more than 5 Eigenfaces. And also, do you think we should include an input for the user to choose the image size, which will actually determine how quick or slow the application runs?
The code limits displayed Eigenfaces to 5 by setting the maximum number of components, max components, to 5 when posting the data to the SVD worker. So even if more images are captured, only the top 5 Eigenfaces, based on the largest singular values, are visualized. This cutoff is based on a trade-off between having enough information to capture the main variations in faces and keeping the visualization and subsequent processing manageable. Regarding including an input for the user to select the image size, doing so could offer more flexibility by allowing users to control the trade-off between processing speed and image resolution. Larger images might provide more detail but require significant processing power and could slow down real-time performance, whereas smaller images ensure quicker computation and smoother interactivity.
Okay, so first of all, we need to make it clear in the interface that the 5 Eigenfaces is the maximum at the moment. So essentially there's no point keep capturing faces after the 5. Is that correct? And yeah, how do we add the slider for the image size, keeping the current one as default, but giving an option to actually go all the way up to the video capture size?
Below is the plan with corresponding changes. We'll add a slider input in the HTML, for example in the camera input section, so that users can choose a capture size from 100, the current default, up to the size of the video, for example, 300. In main.js, we'll define a global variable, for instance image size, that is updated when the slider value changes. Then in the event handler for capturing a face, we'll first check if 5 faces have already been captured. If so, we disable further capture and update the status message accordingly, and then use the current slider value instead of the hard-coded 100 when drawing the video frame on the canvas. Note that because the Eigenface extraction and reconstruction depend on the number of pixels captured, all parts of the application that currently assume a 100 by 100 image, in visualization and reconstruction functions, will now work with the dimensions the user selects at capture time. You may eventually want to propagate the chosen size to every part of the UI so that the images, Eigenface canvases, and reconstruction are rendered at the chosen resolution. Below are the code changes you would need. HTML, index.html. Add the slider input element in the camera input section.
So I'm having trouble integrating this, and that's not fun. It's actually managed to doesn't work. That's a bit weird. Okay, so that goes in there. Can we add an option to change the captured image size, keeping the current value as default?
I'll implement an option to change the captured image size while keeping the current 100 by 100 size as the default.
Working pretty well. Yeah, we now have an option to choose your image size. Anyway, have to test it some more and eventually we'll release it into the wild. Go check out our website. Everything we do eventually available on this page. So go check it out. Don't forget to provide your feedback. See you next time. Bye.